Hi ladies, in this video we're going to go through the more difficult questions in 6H. So just scrolling back up to look at the key ideas. So this is fractional indices. So understanding these rules is extremely important. So if you haven't done the beginning part of 6H, I strongly encourage you to do that because fractional indices relates to surds, and this is probably the first time that you've seen surds, so you really need to cover that theory beforehand. All right, so let's quickly go through some difficult questions. So I've put question 7 on because you're not using a base that's a pronumeral, you're using a base that's a number. So when it says evaluate, basically we need to get it into a number. As simple as that. So I'll just write over here. So let's have a look first at 7a, 4 to the power of negative a half. So we've also got negatives in here, I just realized. All right. So sometimes to understand what is actually happening here, you can always separate your surds if you like. So 4 to the power of negative a half is the same as 4 to the power of a half to the power of negative 1, because a half times negative 1 is negative a half. And you can also do that the other way if you like. Okay, so either way is fine, and I'll show you both ways. Now, this is an index law in itself. I don't think actually, I'm looking at the questions now. Question 9 looks like we would be using this process, but this is just to help you understand, well, we've got a negative there and we've also got a half. So the half is the same as the square root. So we're going to take the square root of 4, and that's the power of negative 1. Square root of 4 is 2, so then it's 2 to the power of negative 1. And I might just scroll so I've got a bit of room. Now, 2 to the negative 1, just always think this is the same as 2 over 1. So when it's to the negative power, we just take the reciprocal. So it's a half. And that negative 1 now becomes a positive 1, so it's 2 to the power of 1, but we don't usually write 2 to the power of 1. So 4 to the power of negative a half becomes a half. Now, if you wanted to do it the other way, so 4 to the power of negative 1 is 1 over 4. And then we've got that to the power of a half. Now, when we've got the index on the outside of the bracket, both the numerator and the denominator is taken to the half. So we're going to have, well, I'm going to do the square root of 1 over the square root of 4. I need to scroll down a little bit more. The square root of 1 is just 1. And then the square root of 4 is 2. So either way, you get the same answer, obviously. If you didn't get the same answer, you've probably made a mistake somewhere along the line. But you choose which method suits you. And you don't always have to separate it. Some people know straight away that negative, I got to take the reciprocal. So you flip it like we did here. But it's a rule that you'll think, well, sometimes it's easier to do it the way that we did on the left-hand side. Sometimes it's easier to do it the way we did on the right-hand side. All right. Let's have a look at another question. So girls, I'm in the classroom and I think the year 12s are going a bit crazy. All right, let's do C. Okay, so we've got 32 to the power of negative 1/5. And when I say crazy, it's kind of like, I wonder if they feel like it's their muck-up day because it's the last day of school. All right, or they feel like it might be their last day of school. All right, let's move on. So 32 to the power of negative 1 over 5. So it's a good idea to separate it. So I'm going to separate it. Oops, I didn't put it on. Oh gosh, sorry, I'm getting distracted. I'm going to do it 32 to the power of 1/5, and then to the power of negative 1. Now, the reason I've done it that way is I just feel like 32 to the power of 1/5 is the 5th root of 32. and then we take that to the -1. I just feel like this way is easier. Now, eventually you'll get to know your roots. So the fifth root is 2. So 2 times 2 times 2 times 2 times 2 gives you 32. So the fifth root of 32 is 2. And then we've got to the -1, and that is equal to 1/2. So you could have done it the other way with your powers, have the -1 inside the brackets and 1/5 on the outside. Personal preference, girls. All right, let's do one more. It's pretty much the same method each time, but let's do h. So 256 to the power of -1/4. Okay, so I'm going to separate my powers. All right, so the 256 to the power of 1/4 is the fourth root. Now, you don't have to write that's the root sign, okay? It's just helping you know that to the power of 1/4 is the same as taking the fourth root. All right, so what number multiplied by itself 4 times gives you 256? Now, if you have trouble doing that, remember you can always do your, what do we call it? The prime factor. Oh, I'm getting distracted quite easily. I'm going to do it. Your prime factor tree. All right, so I'll do that over here. Okay. Sometimes it's easier just to think of numbers in your head, but let's do it like this anyway. All right. So let's split them up. Because it's an even number, I know 2 goes into 256. So half of 256 is 128. All right, then I'm going to separate that again. So I'm going to separate that into 2. Oh, but we're doing the fourth root. Okay, I'll show that to you in a sec because 2 is also a base. 128, so that's going to be 64. And then we can do 8 and 8. Let's just separate that. So we're going to have 4 and 4. Oops, not 4 and 4, 4 and 2. And then you're going to have 2 and 2 and 2 and 2. So, 2, 2, 2, oops, 2, 2. So 256, if we were writing it as a base of 2, it's going to be 2 to the power of 1, 2, 3, 4, 5, 6, 7, 8. Missed that, so just count again. 1, 2, 3, 4, 5, 6, 7, 8. But we want the fourth root. So that is the same then as 4 to the power of 4. So if you wanted to, you could group your 2's. So we can say, well, that's a 4. There's a 4 here. There's a 4 here, and then we've got another 2 4s. So sometimes breaking your number down using your factor trees can help you find the roots, but I often would just do them in my head. Okay, so the fourth root of 256 is 4. So we've got 4 to the power of -1, and that's going to give us 1/4. All right, let's clear that and do another question. So question 8. So here we're going to be looking at Pythagoras' theorem. So our next topic is actually going to be trigonometry and Pythagoras. So Pythagoras' theorem is c squared equals a squared plus b squared. So basically that means when you have a triangle labeled A, and it has to be a right angle triangle, you can't apply it to all triangles. C is always your hypotenuse or the side that's opposite your right angle. So sometimes you might get a triangle and it's a bit hard to see which side is the longest. It's always the longest. But if it's too hard to see, it's the side that's opposite your right angle. And A and B can be either of those two other sides, but C has to be this longer side. Now you can see in this question, they've labeled C anyway for you. So it's, they've done a little bit of the work. Okay, let's just pick a triangle. So I'm going to do D. Oops, should probably draw my triangle first. 5, and 10. And then we just substitute into Pythagoras' theorem. So I've got c squared equals, now you can label them A and B if you like. Doesn't matter your order because we're adding them together. Okay, so 10 squared is 100, 5 squared is 25. So c squared equals the square root of 125. And, oops, so we took the square root of both sides. So c is equal to the square root of 125. Now, when we do thirds, we can actually simplify this further, but at this point, you don't have to simplify it any further, but I'm going to do it anyway because some of you might be interested in what I'm saying when I say simplifying thirds. Oh my gosh, that makes so loud. Okay, so we've got the square root of 125. When we're simplifying, we say, all right, what square number goes into 125? So 25 does, and how many times does it go in? It goes in 3 times. So then we can separate them. So the square root of 25 times the square root of 3. Now the square root of 25 is 5, and then we've got 5 root 3. So when we do thirds, that's what we're going to do, but we can leave it as the square root of 125 for now. But you may have put it in your calculator to check and you got 5 root 3 and you're like, oh, how did I get that? Okay, so it's just simplified it. All right, I don't have much time left, so I'm going to just quickly look at 9 with you. So note that 8 to the power of 2/3, so you can see they've separated the powers there. Okay, and so they've done it, okay, no, they've done it. You could have done 8 to the power of 2, then to the power of a third. So that's what I mean. There's 2 ways to do it, but sometimes one way is a lot easier than the other. So they've actually chosen the easier way. Let's have a look at A. Okay, and I'll show you what I mean by doing it 2 ways. So first of all, we could do 27 to the power of a third all squared. So we're taking the cubed root of 27. Again, you don't need to write the root if you understand that that is the cubed root. So what number multiplied by itself 3 times gives you 27? That's 3. So we can do 3 squared, which is 9. Now, if you wanted to, you can put your powers around the other way. So we have 27 squared. And who wants to do 27 squared, really? So you can see sometimes one way is better than the other. So if you went ahead and did 27 to the power of 2 to the power of a third, and you're sitting there thinking, oh my gosh, why is Miss McMullen wanting me to do my 27 times tables or 27 times 27? Yeah, look at something easier. So there must be an easier way. Usually in maths, you do need to do a lot of things by hand, but if you're expected to do things by hand, they're supposed to be pretty at your level. So you're not supposed to know 27 squared. All right, so let's have a look at just another one. I might do 4 to the power of 5 over 2. So this one here, the same thing, split it up. So you can put it to the fractional power first and then 5. So you got to think about splitting them up. Oops. So half is the square root. So then we have 2 to the power of 5, and I know that's 32. Now, if you did it around the other way, 4 to the power of 5, it is possible, but it's annoying, and I'm not going to do it. So doing the fractional power first in the brackets in these, probably for all these questions, is going to be a lot easier than doing the integer and then the fractional power. All right, girls, bye.